Hey folks, just gonna start up in a second. Starting up in a second. Welcome! G'day everybody. Thank you so much for joining me this morning, this Monday morning, bright and early, week 10, 11 a.m. Australian Eastern Daylight Savings Time. Welcome to Comp 1720 6720. Well, you know we're on the home stretch when it's only the most committed folks joining us for the lectures. Now, I know I can see a few of you joining me here on YouTube. There's a few on Twitch. If my streaming key is working, Twitch had all kinds of issues over the weekend, which we won't need to go into, but where we're at is that I'm going to be giving lectures on some special topics, I guess, for the next 3 weeks. These topics aren't required for you to complete your major project. You've learned everything you need to know in order to create a really interesting, engaging, interactive, artistic work in P5. But these are particularly relevant kinds of recent focuses of work within interactive art, computer art, which are very relevant to P5. So now that you've got your basic skills in P5, you know how to make lots of different kinds of work, lots of types of interactions, then you might think a bit further about deepening the kind of artistic engagement you're doing. So the 3 topics over the next 3 weeks are going to be related to that. And the first of these topics is talking about data. Talking about data. So the real question, well, the provocation I want to give you is that so far, if we've just been using the tools I've given you in the course, you know how to create arrays and objects directly into P5. But given what we've talked about in the course, you don't know how to load data in from a larger data source, for instance, a CSV file or a Json file, and you don't know how to load data from somewhere else on the internet. And these are both really interesting ways to enhance an artwork by connecting it to the real world, connecting it with data that exists in the real world. And it's more convenient when you're doing that to store your program file, your sketch.js file, separately from your data if you have it within your sketch. Or you might have some kind of sketch which accesses the internet to grab some data, which is fantastic too, because then your sketch would be different every day or every minute or every second as that data is continually updated. So this week we're going to have a look at all of those ways of doing things. We will look today about some, I guess, the programming principles behind this, and then on Thursday we'll have a look at how to do this within or how other artists have been doing this within their practice and what data art has been doing in recent times, in the last 10 years or so, and particularly in the last 1 year. One of the funny things about data art, I guess we'll cover this, but artists often use data art to comment on current events in the world because there'll be some data about it. So there are a lot of artworks recently that are about like COVID-19 data or vaccination data or something. And before that, in Australia, when we had bushfires the year before last, then there was a lot of data artworks about bushfires, and there have been continually over the last 10 years or so, many data artworks about climate change, which is something that, of course, I and many other folks feel really passionately about. And artists find ways to express their views about that and communicate climate change in a different way by creating an artwork about it that engages directly with data. So it's a really interesting way of engaging with scientific data or stuff from the real world, which can sometimes seem like it's overwhelming, just seeing like spreadsheets or facts and figures. So we can use art to communicate these things in a more interesting way. Anyway, that's enough for the preamble. I'm going to get into admin mode for a minute. I've got my cup of coffee. You can see your cup of coffee there on the desk. I'm going to make myself small so I'm not overwhelming you folks with my dramatic presence. The to-dos for this week, the week 10 to-dos. First of all, if you're in Canberra, make sure you're enjoying the lovely sunshine, the spring weather. I'm wearing a jumper this morning because it was a little bit cooler than we might have hoped, but hopefully it'll warm up a little bit and I can take my jumper off. This week, you have a very specific goal to meet to get to Lab 10, and your goal is to start your major project. And this is fantastic because it means that by the end of this week, everybody in my class, everybody in Comp 1720, everybody in Comp 6720 will have started their major project, and that fills me with a sense of relief and confidence that everyone is going to get this done. You should know that I am very concerned about all of my students, and I'm particularly concerned about students who, for whatever reason, end up tripped up at the last minute in their assignments, and I really don't like seeing that happen. And so one way to try to avoid that is to, just put a little bit of pressure on you folks to make sure that you're starting your work early. And the way that I'm doing that at the moment in this course is to require you to sort of deliver these little steps in your making sure that you started your work. So the requirements in small details or practical requirements for week 10 is you will have had to fork the major project repository. You will have had to start some aspect of your MP, make some kind of sketch, commit it into Gitlab, and then post it on the forum and bring it to your lab so that you have something to talk about. We'll just have a look at the lab page before we go too much further in this lecture. This is Lab 10, starting your major project. Oh, someone's got some great comments for me already. Could you post the links to your lecture sketches again? I will in a minute. Or I can just show you right here. Lectures, open, lecture sketches. It's right here. Those are the, whoops. Where's my sketches? Maybe I don't have it here. Well, I wonder where it is. Where's my collections? I'll do it right now before I move on. I won't because I'm in the wrong window. I'll find it for you later, but I should put it on the lecture page, shouldn't I? Is it really not there? That's the labs. Oh boy, that's very slack of me. I'm very sorry. It will be on the lecture page for you a little bit later. That's annoying that I didn't do that already. Let's go back to week 10 lab. You've got some numbered advice here. Fork the major project and clone it to your computer. Take one aspect of your major project and try to implement that. Implement a sketch. Commit it into your MP repository. We're not expecting you to have finished an aspect of your work, just to have started something, made a sketch so that we can discuss it, iterate it, think about things. Commit and push this to GitLab. Take a screenshot of it, add it to your pre-lab post, and then in your pre-lab post, I want you to address this question. How does this sketch reflect the major project theme? How does this sketch engage the viewer? And what's the address of your sketch on the test server? So we want to be able to click on the link in your pre-lab and go to the sketch server on the test server and see that sketch there. So, you really have had to make it a start. You have to do this in P5, not just drawing pictures and taking a photo of it. And you need to make something that does reflect the theme and, you can explain that. You should have discussed that a lot last week in your labs. And you need to try to engage the viewer with your sketch. There's some discussion in the chat. Someone's just posted my collection of sketches from the lectures. Thank you so much for doing that. I think I've caught them all. I go through regularly and I just add any extra sketches that I've forgotten. I know things have gotten a little bit crazy with the sound lecture. There were many sketches we tried. We'll probably try a lot today, so I'll add a lot today. Hope you enjoy that. It's a slightly unorganized collection of ideas in there. The wonderful thing after this lab, as I said before, is that once you get to your lab, you can pat yourself on the back because you will have started your major project for Comp 1720, 6720. That will be such a good feeling if you haven't done it already. There's some discussions in this lab about interaction, recent developments. We were discussing that last week, and recapping some of the many things we've talked about in this course. I guess I'll just say a little bit about this section. After the rest of this lab in task 3, it's not really an exercise per se. it's more just a list of topics that you can go through just to recall something. You might want to revise something, just to remind you about some typical ways that we would do, we would be dealing with different ideas in P5, dealing with fonts, dealing with objects, dealing with functions, doing scene management. We've talked a bit about that. Push and pop, what that might mean, content licenses. These are important topics. If you know all of that stuff, then you can kind of tick this off pretty quickly. But the task is just to have a look at these and revise something that you might want to talk about. Just choose one that appeals to you and have a discussion with your group. So I know some students get to this point in the lab and they think, oh, do I have to really read every single one of these? Well, no, it's a list of different topics. You can read the ones that you need to or want to. And if you already know everything about fonts, then you don't need to read that section. But task 2 and task 1 are really things you need to think about. Okay, one more little mention. Gitlab. Getting lots and lots of comments about Gitlab at the moment. There's something funny in the state of Gitlab right now. Something is amiss. The way that Gitlab works, just to demonstrate this, is that we have there's the website. Oh, no, that's the wrong color. There's Gitlab, the website. Then sort of behind that, there's it's still the wrong color because it's going to be green, red on red. I'll use green. That's more contrasty with everything. Then behind that, there'll be some the Git repositories. And then we've got some other, I don't know how many computers this is. This may be one computer, but there's all the places where your actual code is stored in the Git repositories. And then there's a website which gives you, the website's called gitlab.kex.anu.edu.au, and that gives you access to the Git repositories. But usually when you're actually committing code from VS Code, it skips the website and just takes it straight to the Git repositories. So the Git website is a different way of accessing, this is the code here. Sorry, I'm getting technical for a minute, but I'm just trying to explain something because people are telling me GitLab's broken. And I'm like, it doesn't look broken to me. Well, what they really mean is that the CI jobs that are doing deploy and checking for your statement of originality and checking for your thumbnail.png files, the CI jobs actually runs on a different computer. CI stands for continuous integration. I'm not even going to try to explain what that means yet, but basically the idea is that with a code storage system like GitLab, every time you push some new code to it, it includes a system to run some checks on that code to make sure that it works and do something with it. And what we've chosen to make it do is publish it on your little website, the test server. So then there's the CI jobs run on this CI job. It's called a runner. That's a different computer. And this one, something up with that one. We're not quite sure what's going on. And then actually there might be even a different computer, which is the test server. So we've got lots of computers here. So, you know, the likelihood of all these computers breaking on the same day is low. But I'm having some issues with the test server, and I'm having some issues with the job runner, as far as I'm aware. I don't run these things. I've just sort of sent a support request to our fantastic IT team within the College of Engineering and Computer Science. And they're going to figure out what's going on with the CI job runner and what's going on with the test server. All of this is to say that, in fact, you're still committing and pushing your code to GitLab. It just might not show up on the test server, and it might be that your CI jobs don't start properly. So you'll be able to see that on GitLab because you'll get this little exclamation mark. Well, mine says pipeline passed, but you might get a cross or something on your major project repository because it's not worked until our job runner starts to work. And you might click on this angry red cross or something and see, oh my goodness, my things aren't working. I've got failed jobs. Failed jobs, that means my push hasn't worked. Well, no, your push has worked. If your push hadn't worked, it wouldn't know to run the job. So you commit, you push, that's done. and then the GitLab server itself decides to run the job. So if it doesn't have your code there, it can't run the job. So your code is there, been correctly submitted and pushed, but it hasn't run it. So I'm sorry because it's delaying like seeing folks' major projects. It's very annoying. But hopefully we can sort this out today. But just your committing and pushing is working fine. It's just the jobs which are a problem, and that really is a separate issue. Yes, so these ones ran ages ago. You can see that this one was successful, and that was 2 months ago. So I'm just giving you an example. Okay, back to the lecture, the work at hand. We're just going to talk a little bit about the 2 documents you have to write for your major project, because within your major project, you have to do your code, you have to do an artistic statement, but we've got another document for you to write called an interaction statement. So for the major project, you have to write an interaction statement as well as an artist statement. And I just want to mention this now. You probably won't write this for a little while, but the point of the interaction statement is that it's a step-by-step explanation of what your experience is supposed to be for a viewer. What does the viewer see? What attracts their attention? What are the meanings of what they see? How do they interact? What happens when they interact? How do they know what to do? And you do this for each step that the viewer is supposed to take through your artwork, if there are such steps. Why do I want you to write this down? Well, sometimes it happens that students create an assignment that seems very obvious to them what the viewer is supposed to do, but to me who's marking it, it's not obvious at all. And then I get confused and I don't know if I'm missing something about this assignment. So you look at it from my perspective, I'm seeing more than 200 major projects. I have a small amount of time to try to understand each one, and if I get confused, I get a bit frustrated and I don't know what's happening. So the idea of the interaction statement is that it's your chance to explain to me what I'm supposed to be seeing, hearing, doing, and then I can do that. And of course, in many cases, the interaction statement is exactly the same as the experience I've just had, but of course, if they're not the same, then I know to do some investigation about why that might be the case. Remember, for Comp 6720 students, that you must also explain in your interaction statement how the interaction reflects recent developments in the topic of this course, the interactive art field. So that's an important extra thing for 6720 students to do. Don't confuse the interaction statement with the artist statement. We've already done a lot of discussion about what artist statements are. The interaction statement is what they will do, whereas the artistic statement is about what you're trying to communicate to them with your work. So if you need more discussion or you want to revise about that, remember the week 6 lecture I gave about what an artist statement should be, and make sure you do start early on those interaction statements. Start today as you're writing down your sketch. Start to list the things you want to happen in your sketch, and over time you can edit that document. Just a word of warning about academic integrity, I guess, in major projects. We don't mind in this course if you are adopting ideas from other folks, other sketches and examples you find on the internet, but you need to do 2 things. First of all, and most importantly, you need to put this in your statement of originality. And second of all, in all of our assignments, and particularly the major project, we expect you to change this work significantly. So make sure you've taken inspiration from something and taken it to a different place, or changed it quite significantly, adapted it for a different purpose or your own ideas. And really, it should be quite different than what I'm seeing online. If I see a major project that comes in which is mainly code from the internet and it hasn't been changed significantly, but it is in the statement of originality, then that code is going to have a hard time passing, because we expect you to be demonstrating your abilities. And if your abilities are only copying and pasting code from the internet and not changing it, and not adopting it to your purposes, not making it your own, then that's not sufficient to pass this course. So just be very careful about that. Of course, I want you to be looking at examples, taking lots of inspiration, but change things, play with them, wrestle with those ideas, make them different, use them in unexpected ways. And even if you have significantly changed the code, we do need to see it in the statement of originality. this final thing is important. We don't mark you down for borrowing ideas or adopting ideas that you've found, taking inspiration, but we need to see that you've done significant work, and we need to see that you can explain where those ideas came from. That's just a word of warning about academic integrity there. Okay, topic of this lecture, working with data. Working with data. What is data? What might data be? What indeed? Sometimes when we think about data, we think about this kind of crazy internet tubes, flow of undifferentiated zeros and ones. I suppose this is a very low-level way of thinking about data as bits traveling down some kind of physical connection between computers, or bits stored in RAM. But really, we're thinking about somewhat more structured data in this lecture today. Data that you might find describing certain things, and it has built-in interesting structures that we want to access in P5. So you've worked a lot with data already. You know how to use variables, you know how to use arrays, and you know how to use objects in your P5 sketches. And these are all different ways of representing data within P5. But what if you want to use a lot of data? Lots and lots of things. It might be, in fact, too much to actually store it within your sketch.js file, this one, and you might want to load it in from some separate file. So have a file outside your sketch.js, maybe a .csv file, and load that right into your sketch. Whoops, that's supposed to be an arrow. You might also want to load data directly from the internet, which is where things get to be pretty interesting. So this is what we're going to look at this week. What kind of data could we do this with? Well, I think one of the most typical kind of the data forms that most of us know about or learn about when we're kids is storing data in a spreadsheet. It's a great way of looking at data, viewing it, editing it, and storing it. So here's an example of a spreadsheet, typical kind of data source. But we could also have data stored in a text file. It could be some big, long file like the complete works of William Shakespeare. That, of course, is about a megabyte of text, just raw text. And certainly, that could be a big data source that could be loaded into your sketch. If you had to load the complete works of Shakespeare into your sketch by itself, your sketch file would be mostly data and a very little amount of code. We don't really want that. There's other kinds of data, for example, MIDI data, musical representations of notes that you could be thinking about as well. So there's lots of different interpretations or ways of representing data and ways of interpreting it. So the 3 steps for data art that we're going to be thinking about today, I guess, is number 1, getting data into P5 in some way, usually as arrays or objects. Number 2 would be accessing elements of this data. How do we get at it? Similarly to what we were doing with arrays and objects. And then finally, number 3, what can we do to draw, move, sound stuff on the screen based on that data that we've loaded in? And this is the bit which, I think by this stage in the course, you folks are really on top of that. Tick, tick, tick. You know how to draw some pictures, you know how to do all kinds of things, moving things, interactive things with P5. And you're pretty confident with this, and really the only one we need to go over is this one, actually the getting the data in. So this one you know how to do because you've done a lot of that work with arrays and objects. Okay, so first thing, tables. This is just like a spreadsheet. It's a way of loading in some kind of tabular data into your P5 file. And instead of reading your typical Excel spreadsheet file, .xlsx files, P5 most easily reads CSV files or a comma-separated values file. So CSV files are very easy to make. They're just a plain text file, just like your .js files, with a .csv file extension. You can just make one in a text editor like VS Code, Or if you've got a spreadsheet already in Excel or Numbers or Google Sheets, you can usually export it as a CSV file, which is, it's often more useful just to be editing your data source within a spreadsheet program and then export the CSV file, then edit the CSV files directly, as it turns out. Tables. Here's an example of a table. I'm going to have some kind of a list. These notes I wrote a year ago, so in fact I've forgotten what these mean, but let's just try to deconstruct this. I know that I've got rows here, and I've got columns, and my first column appears to be the names of animals. Kangaroo, echidna, sugar glider, noisy miner, and magpie. And I think these are animals that I might encounter near my house here in northwest Canberra. So then I've got another column with some numbers and some other columns here with some other numbers. And in fact, I don't know what any of these columns are now because my table doesn't have any information about what has been stored. But we could put this table into CSV format fairly easily. We'll just put quote marks around the strings of text and just leave the numbers as is, and then in between each value we're going to put a comma. So far so good. Oh, I'm just getting, there's some action happening with our GitLab service request, so I wonder what's going on there. Oh dear, there's something going on with that server. Not a very good server doing our CI jobs. Sorry about that. Hopefully it is fixed soon. Making a table in CSV format. So here's my simple table. I still don't know what these numbers mean though, because I've forgotten what I was intending. So hopefully the next slide will help me out with that. Now we're getting somewhere. We've got a header row. So often in a CSV file, the very first row, or the 0th row, will be a list of the meaning of each column in that file. So the first column, I think, is going to mean the animal, the name of the animal. We already worked that out. The second column is going to mean the number of sightings of that animal, the count. So I've seen 12 kangaroos. I've seen 1 echidna. I've seen 3 sugar gliders. I've seen 263 noisy miners. There's a lot of those birds around. And I've seen 5 magpies. I spelled that incorrectly. It should be like that. The number of legs of each animal. So kangaroos have 2 legs, echidnas have 4 legs, sugar gliders have 4 legs, noisy miners have 2 legs, and magpies have 2 legs. The number of arms. The only animal that really has arms is a kangaroo. It's got its little 4 legs are kind of up like that. And the number of wings. Of course, the birds have wings, 2 each. And sugar gliders kind of have arms that are also wings. So that's a bit confusing. Or it's got 2 big skin flaps between its arm and legs to make a surface for gliding. I haven't seen any sugar gliders recently, but I did see a few last year around a bushland, which was pretty special. Okay, so this is my CSV file all edited up. And what can I now do with it? What am I going to do with it? Well, I can save it as a file next to my sketch. You might put it in your assets folder if you're using this within one of the projects for Comp 1720. And then P5 has this load table function. Well, I might see if I can select that in the reference. We can have a look at that in a minute. Whoopsies. Oh, I want it to be in a different, oh, I've got it in a different tab. That's good. So I'm going to say data, this is going to store my data. Load table, assets/animals.csv. I'll give it the type of file as a CSV file, and I'll say header, which means just telling P5 that my data has a header row. So let's just have a brief look in the reference at load table. You put this in your preload, by the way. That's a good thing to put in preload. So we've got loading up our assets here, mammals, and then we're doing some stuff with it. But I just want to know, oh yeah, here we got file name, the extension, the type of file it is. It could also be semicolon separated values or tab separated values. You can't just load up an Excel spreadsheet here though. And if you have the header row, you can include that header string to tell it what to do. Okay, and I think what we should do is try it in a minute, but I'll just show you broadly what will happen once we get this data loaded up into P5. We can get rows from it, get a row by a number, so it's going to look through this the CSV file and assign a number for each row as if it was an array. We can get a column out at one time, and we can give the column by name. We can get a row and then get the column from that row, and that will get us one particular element. And then if we don't want to use this kind of get column, get row notation, we can also just change this into a 2D array and then use indexes to get at particular elements. So that's a simpler way of doing it sometimes. I think I'm gonna, well, I'll just show you how this works and then we'll have a look at a praxis and have some fun. So I've already got my animals.csv here. This is my, I'll put week 10. Week 10 CSV files. I'm going to add it to the collection while I'm at it. Add to collection. Okay, I'm going to make a preload function to load it up. Preload. And just have a look at this CSV files. By the way, if you're in the editor, the P5 online editor, you can go into the little column here and just type create file and enter your name of a new file. You can make new files and put text in them whenever you want. So I've got animals.csv. I might just go back to my slides and copy out that important animal data. And we can see what, oh, it's not right. There's my animal data. Or maybe it's too much data. I'm not sure what's happening here. It hasn't formatted it correctly. That's okay. I can just format it right now. Got my kangaroo, got my echidna, got my sugar glider. I've got my noisy miner, and I've got my magpie. Just going to delete some of those spaces in here so that it's not as much of a mess. Okay, a very simple CSV file. Now I'm going to load this CSV file in my sketch. So I'm going to just go back to where I had that explanation of how to do that. Here it is. Let data. So I've got my variable data. I'm going to load table, and I haven't stored this in an assets folder. I might just do, I wonder if you can easily do that. Move? No, it's going to be hard to do that. I'm just going to not do that for now. If you're doing this in one of your assignments or your major project, remember you need to put everything that's not a JavaScript or an HTML file into your assets folder. It's a bit annoying to have to do that, but that's the situation we're in. Okay, well, I guess we'll start and see if this works so far. So far, so good. Seem to have successfully loaded this table. Maybe I'm just going to print data just to see what it is. This is always fun to print things and see what happens in the JavaScript console, because it will let us just see what this object is. You can just look at it. It's great. Okay, so we've got a list of columns, an array of 5 things. There's all my columns. We've got a list of rows. And those are each of the sort of significant data rows. Each one of those are an object with all of these properties. I've got a function called add row. I can add rows to the table, remove rows, or get a row, get multiple rows, find row, match rows. So you can do lots of rather complex things if you've got a big table. We might try out a few of those in the next demo. But for now, I'm just going to do a not print data. I might print data dot get row. Is that by number? I think it is. Get row 0. Okay, there's my row 0. And then once I've get my row, I can get objects out of that. Get row 0 dot get animal, and get the, let's see if I can see what the animal is in that row. And it is in fact a kangaroo, which makes sense. You know, let's draw with this for a little bit. Can you iterate over these things? Someone remind me how to iterate over an object in P5. It's skipping lost in my brain somewhere. I don't want to do it that way. Oh well. For let's row number, or let I equal 0, you know, I less than data get row count, I think is I should be looking up the table reference. Reference, table. Rows. Rows, rows, rows your boats. I plus plus. Equal data dot get row I. Is this going to work? So far, so good. Okay, I'm going to print out the. Well, I might do this all in setup actually, not in draw. I just want it to happen once and be done with it. So function draw can just do nothing. Prints animal dot get animal. I'm just getting its name actually, not the whole animal. There I go. I've got all of my animals there, and maybe I'll draw something with that data. Ellipse. It's going to be random width, random location on the screen. But the size of my ellipse will be related to the number of arms and legs. So the it will be animal.get arms times 50 and animal.get legs times 50. So the size of my ellipse here is going to be, in some sense, related to those arms and legs. And sort of some kind of color there for the fill. And no stroke, I don't want a stroke. Oh. Well, that doesn't make sense. What's going on here? Got one ellipse there, but where's my other ellipses? It should have made at least 1, 2, 3, 4, 5. Random width, random height. What have I done wrong? I want them each to be a different color, so I'll do it this way. I'm just going to I'm trying to draw a different ellipse for each animal in my CSV file, which is a fairly silly thing to do, but at the moment it seems like I'm only drawing one, which is a bit annoying. Very strange. Animal.get arms. Have I made some deep mistake here? Oh, most of them have 0 in one of their in one of their dimensions, which would mean it would reduce to 0. Whoops. See, you've got to make sure you investigate your data first. I'm just going to make sure that I've got at least 1, or plus 0.5 or something, so that each of my little ellipses has some kind of shape. Now I should get 5 ellipses. Oh, they're huge. Oh boy, that's not what I wanted. Oh dear. Well, we're getting something. I might leave it there. So this is my first very silly example of how to make use of this this data, and I've absolutely messed it up. Create canvas. I'm going to make this a bit bigger. Window width, window height. Oh, now I've got these massive ones. Why are they so huge? How many? They've only got 4 legs. They should only be 250 high. $20.5. How many legs do these things have? Oh, something's going wrong there. Well, my CSV file is not very useful at the moment. I'm not sure why they've got such massive amounts of legs. Well, now they've got the right number of legs. Why is it multiplying them by 10 as soon as I add a number? Some JavaScript hacker can explain this for me. Anyway, that's my first go with the CSV files. They're really huge, aren't they? I don't know what's going on with that. Concat. You'll have to provide more information for me than that. I'm doing something really, really weird. Concat. What am I doing? What does concat mean? Convert to num. I need more information. I'm too stupid to understand your information here. Is it I've got some kind of weird object and it's not converting it correctly? I want it to be a number. How do I do that in JavaScript? Help me, help me. Someone's going to tell me in the comments. Maybe returning a string. Ah, might be giving me a string. That makes a lot of sense. That's funny, isn't it? So JavaScript's doing something really weird. So what do I do to get out of this? JavaScript convert string to number. I Google the problem. Parse int. Probably. Number. Oh, now I've got the right number of things. Okay. I was waiting for you clever bananas in the chat to jump in and help me out with my problem. Let's see how I go. Hey, now I've got my thing. So when you get that out of the, when you get that data out of the CSV file, it's going to think that it's a string, which makes sense because it's coming out of a text file, right? So we do have to just convert it into a number if we want it to be a number. There's probably some way of doing this within the table definition. Number, no. Get column, just get a value. Get row count, set string. Returns a string or a number. Well, so far I'm not sure why it's not returning a number, but it seems to not be. Anyway, I've got my little very silly data artwork working. Let's work with something somewhat more interesting. So we've used tables now, and I want to now look at a somewhat bigger file. We'll download this file called worldcities.csv. So this is where things are a bit different because our number of entries, is going to be very high for this. So there's a lot of, this is a database of a large number of cities in the world. This is provided as a service by this company who's been arranging this data. And of course they have a very comprehensive database with 4.3 million places. And they've got a basic database which has most of the most important places available. And it's available under a Creative Commons license. So it's great. We can use that as one of our files in P5.js. Just going to download that, save it. Cool, got it. It's a zip file. And it's 4.4 megabytes. So that's pretty big, isn't it? That's good. I can just extract that, put it on might chuck it on my desktop. And I'm going to load it up. Upload a file. That was on my desktop, wasn't it? I don't know why I'm singing Totoro, but I am. When I'm uploading CSV files into my browser, you of course have to sing Totoro. Okay, we got that there. So now instead of opening animals.csv, I might look at Worldcities. I'm just going to copy its name here so I don't have to look at it that way. Why don't we just have a little bit of a browse of this file? It's going to take a minute to load it up. It doesn't want to show me. It's a big file. It's so big it's too painful to look at. So I might just comment out this artwork, this fantastic animal artwork that I've done, and have a look at the columns of this. I think I can get print data get row count. I'll just see how many rows I've got and see if it'll load. It takes some while to load. It has to download into my browser. And it's got 41,000 rows, so that's great to know. I want to see what the columns are. So I can have a look and see the the names of all the columns with that columns field. That's great. I want to do that. Print data dot columns. City, city ASCII, latitude, longitude, country, ISO 2, ISO 3, admin name, capital, population. That's cool. So maybe we can do something with this. I might do a similar kind of artwork with some random blobs using the population, I suppose. So I'm going to maybe change that to let city. I've got the same code for my for loop. That's no problem to do that way. Let city equal data.getRow. And I'm not going to print things because otherwise my whole console is going to get absolutely full of printed stuff. I'm going to choose a random fill. I'm going to choose a random place for my little blob. And it's going to be city get population. And I wonder what the maximum and minimum of my population will be. Probably maximum like 30 million, right? So I'm going to need to make this a very small circle indeed. Divided by maybe 100,000. Let's see, it's still going to be huge. 100,000. That's too many. 5 zeros. I'm just going to tune this as we go. I'm going to use a variable to do that so I don't have to do it twice. Let's city size equal city.get population. And I'm going to turn that into a number and divide it by 100,000. Just to save time, I think I'm just going to go through the first 1,000 rows, maybe, not 41, or maybe first 100 rows, just to see where we're at, and then do it on 41,000 rows. Because if I press go on 41,000 rows, it's going to slow everything down. Oh dear. Population is not defined. Should have had it in quotation marks, that's why. Here's my blobs. Oh, that was pretty good. There's some blobs of different sizes. I might like to make them a little bit smaller. Maybe actually 200,000. So, you know, this is the part, oh, that looks better, yeah. The loading of the data and the accessing of the data are completely mechanical things. You can do that with the tools I've given you in the slides and just in my little experimentations here. But the choosing of what size for things to be, what colors they should be, that is where it's up to your judgment about what works and what doesn't. So I'm going to add more rows here. We'll do 1,000. Oh, that's a lot of cities. We'll do 10,000. Oh my gosh. So we've got some mega cities and we've got some tiny cities. And we'll do all of them now, 41,000 data points. Whoa. Isn't that cool? So we've got, you know, specks here that might be like a city the size of Canberra would just be a tiny one single pixel or less than a pixel, just disappear. And a city the size of, you know, the Tokyo metropolitan area would be one of these big rows, or something like Mexico City. So it's huge cities that are like the population of Australia basically, and tiny, teeny little dots, just like Canberra. Now, if we were clever, we could use the latitude and longitude data to get us the position of our cities, and we'll get something like a little world map. Maybe we'll try that. Let lat equal number city dot get lat. Yep, that will work. And let's longitude equal number city.gets long. Oh, LNG. And now instead of random width and random height, I'm going to do lat divided by, how does latitude and longitude work? It's divided by 180, it's plus and minus, right? I've forgotten how latitude and longitude work. Divided by 180 plus 1. Oh no, divided by 360 plus 1, because then I'll be working on in plus 0.5 to minus 0.5, and that's kind of what I want to do. Plus 0.5 times width, and then for, get rid of that. Long is plus 90 minus 90. So I'll divide by 180, so I get plus 0.5 minus 0.5, add 0.5, so it's between 0 and 1, and then multiply by height, and we'll see where we get to. And this, if this is a total mess, I was wrong. There's a problem has occurred. A problem has occurred. I'm doing something wrong here. I feel like I've got a sideways world map. Like there's America, and there's Asia, and there's Europe and Africa, which is a bit confusing. That's because I've got them backwards. Latitude should be there, and longitude should be here. Latitude is up, down, duh, and longitude is left, right. And now the world's upside down. Times minus 1. Minus 0.5 times minus 1. Now the world's the right way up. There's the Americas-ish. There's Africa and Europe-ish. There's Asia. That's where all the persons are, isn't it? So you can kind of see where the weight of the world is over in this area. Cool. Okay, so we're doing some data right now. We're making world maps with blobs. We're really existing in a much more kind of realistic place, dealing with large amounts of rows. 4.4 megabytes of data had to be parsed by P5 in order to get our city working. So I'm going to save that. Thanks for going on that little journey with me. I'm not going to go too much further today. We've got another demo to give about JSON, and then there's some work about using APIs, retrieving data from the internet, which I'll save for Thursday. So we've loaded up a CSV file so far and had a play around with that within P5. And that's okay. But CSV files are not the most common way of storing data or transmitting data on the internet. Actually, one of the most common way is to use JavaScript object notation, which is basically just as you have been writing objects in JavaScript, taking that notation and turning it into a text file and storing it separately to a JavaScript file. That's a really common way to share data between websites. Absolutely super standard. So JSON files with a .json file extension, not .js like JavaScript files. And that's just looks like this, just looks like JavaScript objects. So you know all about this already. I guess the only difference here is that the JSON files have to have a quote mark around the property names. It has to have quote marks there to indicate that that should be a string. And you're only allowed specific types. You can't have methods in JavaScript object notation. Of course, that's just part of JavaScript code. You can only have strings, numbers, arrays, objects, or booleans. So you can have sub-objects for each of your objects. And of course, lots of, we'll see actually on Thursday that JavaScript object notation can produce these very complicated files. And in general, a good web browser like Firefox gives you a way of trying to understand that file, just as a special feature. We do very similar stuff to load JSON into P5. P5 has the load JSON function. Data equals load JSON mammals.json if we had a JSON file for our mammals. And then we can access the values just in the same way as JavaScript objects. The JSON file directly becomes a JavaScript object. Now, this is great, isn't it? Because in the p5.table area, to access that data, we had to use all kinds of funky methods that I was having to look up in the references. But now we can load some data which is just a JavaScript object. Isn't that much easier, right? It has arrays, it's got fields, it's got values, it's got normal JavaScript types. And it's just kind of easy to deal with in the p5.table, if we're honest. So there's the load JSON function. Let's just have a little squiz, a quick look at the reference page for it. Here's someone loading up some earthquake data. They're actually loading this directly from a URL, which is great. Isn't that cool? And doing some stuff with it, drawing some stuff about earthquakes. Very interesting. I'm not sure if that is actually available anymore. I think I tried this API and I couldn't get it to work. But yeah, so it's not too much to say here. The path, it could be a file or it could be a URL. The data type, JSON or JSON-P. I don't even know what a JSON-P is. Maybe that's like coming a bit at a time. Well, someone can tell me about that in the chat and I'll communicate their thoughts to you. Yeah, so this is all very simple and very similar to GetTable, except we don't have to go through a lot of extra effort just to understand the data. So let's get a JSON file. I'll make another, save this one, make a new sketch. It's been called JSON in P5. In P5. Finding a good JSON file was a little bit of a trick, but I found this one from the Museum of Modern Art. You might recall back in early lectures we were looking at the Museum of Modern Art collection, and this is kind of a version of their collection, or all the artists in their collection stored as a JSON file, which is really cool. I'm actually going to save this file, and it's now in my downloads. Open file, have a look at it in text editor. It's a very boring text editor. And again, it's a fairly big file. I think this is 3.5 megabytes or so. And it's just got a big array. There's the opening part of my array. I wonder if I can make this bigger. Text size, tools. No. Preferences. I want it to be big. Fonts and colors. No, I don't want to do that. I want it to be big. Thank you. Okay. We've got some person, Robert Arneson, their short bio, to only one sentence, where they're from, nationality, American, gender, male. American is a funny thing to say. Why don't they say USA? Does that mean they're South American or Canadian? I don't know. Their begin date and end date, I suppose, are the beginning of their life and the end of their life. A link to a Wikipedia article that could be useful, and I'm not sure what a ULAN is, but probably it's something interesting. So this is cool. We've got some, we could take this data about different artists and do something with it. I'm not sure what I'm going to do, but let's load it up into P5 and find out. Oh, this is cool. I could probably combine this with my world map and have places that all these people are from. Okay, so I've got my web editor. I'm just going to load in that file while we're at it. It should be in my downloads, shouldn't it? Modified artist.json. There it is. Is it done? No. There it is. Okay, got artist.json. Don't need to have a look at that. Let's just go back to the lecture for a minute and remember how to get these things back. The load JSON function. Might do it in preload function. Preload. And it's going to be called artists. I'm just going to print one of them. Print data dot or 25, the 25th or 26th row. In fact, the first row will be 0. Just want to see what's going on in that file. Spend a bit of time loading it, and there we go. There's an artist, Dana Ashley, American, 1941 to 2000. And this person is female, a woman. So maybe we could visualize the begin date and the end date of all of these artists. I think that might be maybe an interesting thing to do. I can use the old JavaScript object notation to grab that field, begin date. It's going to be their starting date and their end date, maybe. Data day 5 dot end date. Do something with that data. All right, so sorry for clicking the mic right there. It was for of, wasn't it? So this is a JavaScript array. So artist of data. That's how it works, isn't it? JavaScript for of loop. Yeah. This is what I want. Sorry, sometimes I very much forget like how JavaScript works. So we've got to have a variable for each one of those things, and we'll just be for let artist of data. This is a great way to iterate over that loop, over that object, because I know that the top level of that object was a big array of all of those artists, and I can just grab each one in sequence using this syntax for let artist of data. And I'm declaring this new variable to be one of the rows of data. Should be a lowercase d, shouldn't it? Of that variable there. Oh, I forgot to declare it. I think I'll declare it just so I remember. Sometimes JavaScript automatically declares things for you, which I sort of find, I guess it's helpful, but it's a bit annoying because it's like, can't you just let me get it wrong sometimes, JavaScript? Sometimes I like to be told I'm wrong so I don't screw things up later. And we want our begin date and our end date. I'd kind of like to make two little small circles on the screen for our begin date and end date. Actually, also, I just want to find out what the length of this array is. Data.length. So, is length a property, or is it a method of arrays? We'll find out in a minute if it works. Oops, it's not a function, it's a property. Oh, we got 2000. Oh no, we haven't. Undefined. Length of array in JavaScript. I should be able to remember this, shouldn't I? But there you go. Things happen during the semester. You forget how things work. Fruits.length. Well, it should have length there. Oh well, it doesn't seem to want to know. We're going to go across the screen as we do this. I'm going to let I equal 0. It's going to be sort of my X location on the screen. Or maybe I'll use the X location and the Y location to be their birthday and their death day. Ellipse. It's a good start, isn't it? And the begin date is going to be, most of them will be like before 1700, I guess. And who knows when some artists are born and died. I'm not really sure what's going to happen here, but I guess we'll say artist dot begin date. We'll just do this in a raw way. Let's make sure I've got a number. It should already be a number, really, shouldn't it? Artist dot begin date. Artist dot end date. You know I'm live coding because I'm doing things very slowly and have no idea what I'm doing. That's the typical process of making artwork, isn't it? Just trying to experiment and see what happens. And I want the size of this to be consistent, so I'm just going to add the side to be 15, actually 10. Very small little ellipses, and I'm going to make the fill color random. And again, I don't want strokes. No stroke. We'll see what happens. Data's not iterable. That's annoying. Oh dear. Data is not iterable. I would have thought it would just be a big array. Load Json. It's funny, isn't it? Okay, we'll have to do let's artist equal data just I. I'll have to somehow find out how long it is. I don't even know how long that data is. Maybe I can turn it into an array. I don't really know what I'm doing with JavaScript right now. I'm just trying to get some figure out how long this this object is. Data.length. What comes out of that? Index numbers as keys. Well, how do you turn it into an array once you've done that? That's funny, isn't it? Well, I guess I can just find out from my text file how long this is supposed to be. 1, and it goes up to, oh, then not even a useful number of them. Well, I guess I'll take the first 100 or something and see how far I get. Don't want to print that data, that's going to be terrible. Let I equal 0, I less than 100, I++. I made a big song and dance about iterating over that data, and it turns out I couldn't. I might figure out how to do it after the lecture and show you next week, or show you on what day would it be? Thursday. Window width, window height. Now, of course, my window width and window height aren't that long, so all of these artists are going to be off the edge. So I'm really going to have to divide that by maybe the current year. Those are going to be definitely less than that. So now they'll be between 0 and 1. I'm going to multiply that by one by width, and this one by height. So I'll at least get a position in the canvas that I can see. And I'm still not getting anything. That's no good. Number. Back to this number business. I'm not getting anything. Where's my ellipses? I've lost them all. Just going to make random width and random height just to see that I'm not making any completely stupid errors here. Oh, I drew the background over it. Whoops. That's wrong. That's where you do it wrong. Okay, that's just random ones. I don't want random ones, I want non-random ones. I want sensible ones. Okay. Oh, they're all down this end of the screen, so this is not good at all. Maybe I'm going to try to tune this a little bit so that's minus like 1700, 1700 or something. And if they're earlier than that, I guess it's supposed to be modern art. So we'll tune this number a little bit and see where we get. Okay, now we're getting some more interesting numbers. Spreading them out a little bit, I think we'll get everyone's just going to be since 1900, 121 years. That's going to be the modern art era, really, isn't it? Okay, there we go. All these artists. So they're really artists that are in the first half of the 20th century. It seems like that's their main place here. But that's interesting. We might continue this one next week when we discuss loading data off the internet as well. And in between, I'll figure out how to do this the way that I want to do it. One more little point before we stop. When you're dealing with tables of data and arrays of objects, they're very similar. You can think about these things as spreadsheets, with each row being an object and each column of your table as a property. With those names at the top being the column names or the object property names. And this is really the kind of relationship you want to build with your data. So at the moment, I'm a bit lost with that relationship with that particular JavaScript object, but the more you play around with things, you start to figure things out and find a way to present it artistically and usefully. Of course, sometimes it doesn't fall out that easily. That's why art is hard. We will be coming back at this point when we start to load things from the internet. But at this stage, I guess there haven't been any questions for a while, so I presume that everyone is either completely happy or not listening or I'm disconnected or something, but make sure you do take the labs this week seriously. I think that the labs for this week and next week are really the great opportunity you have to discuss with your tutor and your peers about your major project idea. So you'll get a lot further with your major project if you do this kind of playful discussion, trying different ideas out, seeing where your ideas lead you. Then you will come up with a better major project. And I guess I will see you folks on Thursday. So see you later. Have a great afternoon, and good luck with all of your lab work. See ya.